Hello and welcome to Lesson 83 Mystery Solutions. Um, Mystery Solutions is what I would say is mostly a kind of a wrap up to make sure you understood lessons 80, 81, and 82. But it does pose some, kind of interesting questions as far as, how much is the same amount comparatively to other ones. So when we look at the chem catalyst, says suppose you wanted to determine if your tap water contains any lead to nitrate or PbNO32, which is toxic. So obviously you don't want it in your water. Question one was, do you expect the mass of 100 milliliters of pure water to be the same as that of a solution containing lead nitrate? And explain your reasoning. And the answer to this one is no way. It's not going to be the same, because if I have 100 milliliters of pure water, it should be 100 milliliters. Again, water is 1 gram per milliliter. 100 milliliters of it should be 100 milliliters, or 100 grams, excuse me. If I take some lead nitrate, PbNO32, lead is a very heavy element, 207.2. Then you got, what is it? N is 14. You got two of them, so that's another 28. You've got 6 oxygens. That's going to be another 96. So you're talking, something over 300 grams per mole. So even if it wasn't very much lead nitrate in there, it should weigh a little bit more than 100 grams. And so that's the idea there. And then question two, what is the molar mass of lead nitrate? Just did that. It's 300 and something, 207.2 plus 28 plus 96. Should be somewhere around 331 or something like that. Don't quote me on that. And then what would be the mass of 0.1 mole of lead nitrate? You'd take 0.1 times that 331, be somewhere around 33 grams. So if you had a very concentrated solution, it might weigh as much as 133, 100, somewhere 133-ish grams. God forbid if you ever drank that, you'd probably be dead, or doing a lot of this for a relatively short amount of time before your death, or maybe it would just do a lot of nerve damage because you realized, hey, that doesn't taste very good, so you stop drinking it. It's not going to be good for you. Let's just go with that. Then there were some questions like, as we go through this chapter, if you had 10 grams of copper sulfate versus 10 grams of sodium hydroxide versus 10 grams of potassium chloride put into a solution, which one would give you the highest molarity? And again, you'd have to go back and you'd have to look at the molar mass of copper sulfate, of sodium hydroxide, and potassium chloride. And essentially what you would find out is that the one with the lowest molar mass would have the highest molar concentration in the solution, assuming you mixed it all into the same amount. I think in the book it says put it into 100 milliliters of water. So the check-in question then is, you have 3 aqueous solutions that are 200 milliliters each. One is a sodium chloride solution that is 1.5 molar. One is a 1 molar solution of potassium chloride, and one is 1 molar solution of a calcium chloride. Well, the way I look at this problem is that we've got 200 milliliters of each. So with equal volumes, basically all we have to worry about is comparatively, how does 1.5, sorry, it's over here. How does 1.5 molar concentration, which I could just figure out, well, what is 1.5 moles of sodium chloride? How does that compare to the mass of 1 mole of potassium chloride? And then how does that match up to 1 mole of calcium chloride. Then, if we really wanted to worry about it, we could worry about the grams that are involved. And we're going to see the same result either way. But the idea here is if we look at sodium chloride, again, sodium 23, chlorine is 35.45. So if we take that, add them together, we get 58.45 grams per mole. And again, I'm talking about, let's just make it for 1 liter and see what it is. It's going to make our math a little bit easier. If we wanted to, we could take and multiply by 0.2 for the 200 milliliters. It's going to be 2/10 of a whole liter. But if I just multiply that by 1.5 moles, I'm going to get pretty much the same result either way. So if I multiply those together, I get 87.68 grams would go in there. If I had 1 molar KCl, the K is 39, the Cl 35.45. Add those guys together, I get 74.45. Go on to calcium is 40. 2 times 35.45 is 70.9. Add those two together, I get 110.9 grams per mole. So, sorry, it's not grams per mole. Oh, yeah, so grams per mole. And now I have 1 mole of it. So multiply that by 1 mole. The mole's going to go away. Multiply that by 1 mole. Mole's going to go away. And what I would end up with is 110.9 grams there. And here I would end up with 74.45 grams. So I think the lesson being here that I think most people would kind of instantly predict, well, I've got more stuff here in the sodium chloride because it's 1.5 molar. You can't just make that assumption, okay, to determine which one would have the greatest mass, which one would have the least mass. You know, you might think, well, NaCl has the lowest mass, so molar mass, so it's got to be the least. Well, no, because it's got more there. So you have to make sure that you go through and you see what's given. And basically what we see is that 110.9, the calcium chloride, even though it has less concentration at 1 molar compared to 1.5 molar, the sodium chloride, it does actually have the greatest mass. And then second place would be the 1.5 molar concentration of the sodium chloride. And then third place, or the least, which would be 74.45 for the potassium chloride. Again, you would have substantially less than that, roughly 2/10. So take each of these, multiply by 0.2, and you should have a little bit more added to your 200 grams for the 200 milliliters of water. So roughly 200 milliliters of water. So anyway, I hope that gets you through lesson 83. If you have any questions about these darn mystery solutions, always email tyrick@auhsd.net. Again, any issues, computers, what's going on? You just don't get a particular section. Let me know, and we can work our way through it. So anyway, have a good weekend and enjoy watching my videos. I hope I kind of entertained you anyway, or at least was helpful.